Here we go. We have a question, quick sort on linked list. So you have given a linked list and we need to apply quick sort. Before that, we need to first solve this question, quick sort itself. Quick sort is a divide and conquer algorithm. It picks an element as a pivot and partition the given array around the picked pivot. So you have given an array. Its starting position is low. Its ending position is high. The low and high are inclusives. We need to implement partition and quicksort function. So we have given this function quicksort and partition. So just ignore this. I will create my own function. I have just simply this quicksort function. I don't have partition function. I will create my own partition function. So first, I have this my quicksort function and I am passing ARR. The range, low range is 0 and high range is n itself. And so let's learn how quicksort works first. So I have taken this example. In this example, first we have complete array L. We have some pointers L which is low, low points to 0, and we have high, high is n. So I will solve this question using pivot as a starting element. So I have this element as my pivot, and you will see how this particular element will be placed in its correct position, and all the elements in the left hand side is smaller than that, and all the elements on the right hand side will be greater than that. So how we have to solve this? So I have taken this as my pivot, and we have some other variables. First is I and next is j. J will run till the end. J is just for traversal. So instead of that, I will create low. So low is already there. So I will say left. So left and I, left and J. J is for traversal and it will traverse in all the indexes. So we have this. We need to check, is the current element, means the jth element, is it smaller than pivot? No, it is not. So let's move to the next element here. Is jth element, is this jth element is smaller than pivot? Yes, it is. So we need to swap the left and jth. Actually, left is stay same. We need to swap left plus 1 and jth value. Why? Because till left we have all the elements smaller than that. uh, we don't have this element, but this element will be in its correct position, so we are ignoring 4 itself because 4 is pivot. So we have this element and left is pointing to this. Is this element, is jth element, is it smaller than pivot? Yes, 1 is smaller than 4. So we need to swap left plus 1 index with the jth index. So the value will stay on the same position. After that, we have taken one element on the left hand side, so left will increment one time. And you as you already know, j is just for traversal, so j will always increment. Is jth element smaller than pivot? Yes, in this case, yes. So we will swap left with I. So the element is same, no effect on the array. So left increments and j increments. Left denotes how many values have we seen so far which is smaller than pivot. As you can see, these two values is smaller than pivot, which is 4, and we are ignoring 4 because 4 is pivot itself. So now we have this. Is jth element smaller than 4? No. Next we have this. Is jth element smaller than pivot? Yes. In this case, yes. So we need to swap this value with this value. Left plus 1 value with jth value. So let me swap the values. Left plus 1 is this and it is this. So the value will be 3 and 5 here. So we have seen one more value. So left will increment and j always increment. J is for traversal. only. Now we have to check, is jth value less than pivot? No. So move ahead this. So is jth value less than pivot? No. So now j increments here. J increments, j is out of bound, and left is here. Left is here, and pivot is here. Pivot correct position is this. Pivot correct position is this. And as you can see, all the elements on the left hand side is smaller. All the elements on the right hand side is smaller. So we need to do one more step, which is to swap pivot and left. So swap this and this. So 3 will be here, 4 is here. So left denotes the position, and we have this subarray. We need to sort this subarray, and we need to sort this subarray. So let me show you the code how this is done. So we have this. So let me first take another array, 3 1. Let me take this array itself, 2. So let's take other values just for understanding purpose. So our pivot is this, and in this case first our low is 0 and high is n. So let me denote low and high. Here we have low, here we have high. Then pivot is pointing to low value here, then left is also pointing to low value. So this is our left, and j is just for traversal, start from low till high. So high is excluding. Is jth value, this is value, is it less than pivot? Is it less than pivot? No. So let's move ahead. Is jth value, is the jth value less than pivot? Here is the pivot, yes. 1 is less than 3. So we need to swap what and what? ARR, left plus 1 and j. So left is here, left plus 1 is this, and j is this. So the index and values are same, so no effect on the array. So let's move ahead left, and j is always increment. J is just for traversal. So that's how we have to solve this. So after this, I already solved, so you can try this. It will work fine. Then I talked about this left and pivot swap. So here we are swapping left and pivot, and then we are returning this position. We are returning this position, so it will return this position to me. So let so we have solved this, but we need to solve sub array also. So let me show you the code for recursion. So this is the recursive code. Initially I am passing 0 and n, 0 and n. So then this pivot will return me, it will return me this value, it will return me this value. So we need to solve my quick sort array. We are passing this sub array and this sub array. Then it will sort, this 3 will be in its correct position. So 3 will be here, 1 and 2, and 4 is here. So then we have this and this. So this will work, but let's talk about this. If we have single value only, so our low is here and our high is here. So it denotes on the same index. So it will just return the single array. It will just return the simple, and we don't need to return the array itself. Then let's talk about this subarray. In this case, this has my pivot. Then we have this, so it will divide into this and this portions. Then it will divide into this and this portions. So that's how we have our sorted subarray. So let me show you the code, running code. So I have this function my quick sort. I am passing 0 and low and high, so 0 and n. So then we have, if this condition is true, means no value or single value, just return. Then we have partition, low, high. So just we have this partition function. So in this partition function, this code I have already showed you. J is just for traversal, low and high is our range. So it starts from low, high is excluding. Then we have pivot. Pivot we are taking as low, and left we are taking as low. So we need to swap. If the jth value, the current value is less than pivot, then we have this, and we have taken a value, so we need to increment left. And this is a swap function. So let me show you the swap function. It is very simple. You can do this work here itself, but I have built a separate function. So let it submit. Let's submit this. Then I will show you the code, the exact code. This exact code will work in linked list also. So I hope it will work. Yes. So let me show you the linked list code. We have I have taken the same example. So this example, I have taken this example. So first, what we need to do, we have this code. So I am passing start as my head. This is a head. So let us take this as start. Start and end is our range. So here high is n, here end means null. Here end means null. Then let's take pivot value. This is our pivot, and I am taking node itself. So this is my pivot node. Then we have some values as j and left. So left is also from also work from start, and then we have j. Is jth value, means this jth value, is it less than pivot? No, no, it is not. So let's move ahead. Is jth value, which is 1, is it less than 4? Yes, 1 is less than 4. So we need to swap left plus 1 and jth. So let's swap left plus 1 and jth. The value is same, index is same, so no effect. So then left move ahead, and then j move ahead. Then we have this. Is jth value 2, is it less than 4? Yes, it is. So swap this left plus 1. Left plus 1 means left dot next and jth. So the value stays same. Let's move ahead left, and let's take one step ahead for j. Is 5 less than 4, which means pivot? No, it is not. Then is 3 less than 4? Yes, 3 is less than 4. So we need to swap this and this. Here in the swap function, I am passing left plus 1, which means this, and j, which means this. And in the swap function, what I am doing is I am just changing the values. So 3 will be here and 5 will be here. Then left takes one step, j takes one step. Is 7 less than 4? No. Is 8 less than 4? No. Is j and? Is j not equal to and? J not equal to and. Now j is equal to and. So we have this value. Now left is pointing to the middle value. The pivot will be here. The pivot will be here. So we need to swap left and pivot values. So 4 will be here, 3 will be here. 3, then we have 4. So I am returning left. I am returning this node. So why do we need this node? Because we need to solve the recursion. We need to do the same process in the recursion. So we have this code. So I am getting this value. So in the pivot, this is my pivot value. Pivot means breakpoint. This is the breakpoint. Then we need to solve this subarray, this linked list. Then we have this as my linked list. So here and means null, and means null, and here and means pivot. means we are not reaching till the end. So if we have this subarray, we are not reaching this value, and if we have this subarray, we are not reaching null. So let me solve this linked list. We have this 3, so 3 will be in its correct position. After that we have this as a linked list, and it will return this as a pivot. So then we need to solve for this, and we need to solve for this. So let's code this. I hope now you got it. So we have my quicksort function. I am passing the range itself to start and end. There we have a condition. If low is greater than or equal to high, we cannot do this here. We can do this by this. If start is equal to null, means start exceeds end, or start is equal to end, means there's a single node. So we just need to return it. And we have this partition function passing low and high, passing low and high as a range. So I am passing start and end as a range. Then we got pivot. We need to solve the sub list from starting till pivot, and from pivot dot next to end. Here the code is same, but just for array. Then we have partition function. This is the main function. We are taking pivot as a starting value. Then we are taking left, denoting left sublist. J for J for loop. So this code I've already showed you in the notebook. Then we have swap. So we are just swapping. So let's take the swap function. Uh, so we have swap. So taking the data in the temporary variable, swapping the values. So let's give it a try. Let's talk about time and space complexity. In this case, in the worst case, if I am not wrong, quicksort will run in order of n square, and we are using recursion also. So in the recursion, it will take order of n space. So thank you all for watching.